Hello and welcome back to the channel, and in today's episode I'm going to show you how to recreate a very popular Minesweeper or Supper game in Godot 4 engine. What we have here is a simple interface that counts the mines that are on the board, the timer, the possibility to restart, and as you can tell, just like in the classic Windows game, we have the ability to hit the mine and restart the game, or even place some flags where we think that the mines are being placed. And if we cover all of the mines properly, then we win the level. So yeah, let's jump straight into it and let's get coding. Let's start by setting up the project. So here you can see me in the Godot NG project manager. I'm using stable 4.1 version, and I'm going to create new project. I'm going to find the proper folder for it. And I'm going to create new folder called this Minesweeper tutorial, because I believe that's the name of the game. Supper is Polish name. Select the renderer is forward. We will be using Git, and let's create and edit. We can switch to 2D, and I'm going to start as per usual by creating assets folder. And let's bring everything that we need. So let me go copy all sprites and the font that we will be using. And let's bring that in. And let's copy all to assets. We don't really need to set input for this because we will be working with clicks, but go to project settings, and then in environment, rendering environment, we'll switch the background to fully black. Okay, the last step before we can start coding is we will set up the camera. So let's create the main node. I'm always gonna choose empty node and call this main. Let's save it. Let's set it to the main, set as main scene. So this is the scene that's going to be run every time we hit play. Perfect. And then we need to add a camera 2D. I always like to set mine in the center. We will change one thing, and we will change the window size because we don't need that much space for it. So go to project setting, find display window. Mine's gonna be set to 400 by 400. And let's add a new camera so that the window is applied. Now we can see our wonderful pink square. If we run it, we are pretty much set up. Okay, so this is everything when it comes to setting up the project. In the next, we'll start working on our tiles and placing the tiles on a grid. Okay, let's start by adding a component that we'll use to display our mines. So add a child node, find grid. How is it called? Is it grid map or Tilemap? Sorry. We'll use Tilemap. Okay, and to start working with that, we need some tiles and some patterns. So what we have to do is actually properly import the tiles that we need. So basically what we need to do is select all of the tiles, starting with tile 1, ending on tile unknown, and go to import, and we'd like to import this as a texture atlas. Okay, then choose atlas file, and I called mine Minesweeper Atlas. Okay, and then hit reimport, save scenes, reimport, and restart. Yes, please. If you did everything correctly, what's going to happen is inside assets folder, there's going to be new file called Minesweeper Atlas, right? And we can use this in our tilemap by creating new tile set. So let's make sure that we have tilemap selected. And to create the tile set, let's go to tile set, new tile set. And then we don't have tiles here, but we can just drag and drop that. And now we have our tile set working. Let me zoom in. And you can see here that we have these orange or yellow squares, and each square is a tile. And we can tell already that the positioning and the size of our tiles does not really match what we have in our atlas, because we have some offsets here and some spans between our tiles. But we can easily make that work by providing the correct values. So start by setting the margins to 4 and 4, okay, because that's how they're separated. And then we need to provide the separation to set to 8 and 8. And now you can see that our ties are matched in the base size rather perfectly. And then what I could do is just go to the tilemap, select something, and start painting on our tilemap. But we're not gonna paint anything by hand, because that's rather locks us in the rigid frames when it comes to size of our grid. We'll basically create our grid programmatically. So to do that, we need to go to the tilemap and add a new script. So this is, of course, the first of our scripts. Let's go here. Let's create a new folder called the scripts. And I'm not calling mine tilemap, I'm calling mine Minesgrid, but the name is up to you. Okay, we can start coding. Let's, for the start, remove everything. And with a class name, and this is going to be Minesgrid. And for starters, we will export 3 variables here. So the columns number of our grid, I'm going to set this to 8. The rows number, I'm going to make it square, so also 8. And number of mines. And I'm going to set mine to 10. And this allows us to then easily change those properties in the inspector, because whenever you export something, you can easily change those values via inspector. Cool. Then we need few properties that we need for the programmatic tilemap generation. So first is tile set ID, and we can see that the tile set has ID of 0. So that's what we will provide. And then default layer, we are also working with only one layer here, so it's also 0, right? You can find it right here. Okay, and then we need to start working. So let's start by implementing a ready method that's going to get called basically whenever given scene or given node is ready. So first, what we can do is, just to make sure everything works, we'll clear the layer from the start. So just to make sure that we don't have any trash or any leftovers here. And then we will do a double loop. So for I in rows and for j in columns, we would like to place a tile in our tilemap. And to do that, we'll need 2 things. The information about which tile to place. In our case, that's gonna be the cell that has the atlas coordinates set to 2, 2, as you can see in that pop-up, right? And then we kind of need the coordinates for it in our game world, and we need the coordinates of the tile we would like to place in atlas coordinates. Okay, so what we can do just to improve our experience here is go up and create a dictionary here. I'm gonna call this cells. So basically what I will do is create a dictionary that has a key naming the type of the cell, and then the value is going to be the coordinate of this cell in Atlas. So for example, let's start by describing the one cell. So this is the cell with number 1 and its Atlas coordinates are 0, 0. So I'm just going to say vector 2i, and we can use vector 2i's because we know that the vector values are going to be integer values, and that's what vector I stands for. And then moving on, we have 2, which has atlas coordinates 1 and 0. Okay, so I can just start typing stuff right here. Vector 2i, and this is 1, 0. Vector 3, tile C, and that's going to be vector 2i, 2, 0. Then we have 4, which has vector 2i, 3, 0, and so on. Here, I mean, there's nothing there after we click. And that dictionary basically describes all of our cells in our atlas. Okay, now to generate the tiles, we need the cell coordinate. And that's going to be calculated by vector 2 I minus rows divided by 2 and j minus columns divided by 2. So where are we actually placing our cell? And then to place the cell in our tilemap, we're gonna create a helper function, and I'm gonna call this set tile cell. That's gonna take cell coordinates, which is going to be vector 2, and it's gonna take a cell type, which is going to be string. Let's see, or do we need types? Maybe we don't need types. And what we can just do is we can call function that is in the tilemap called setCell. And you can see all of the parameters that it can take. In our case, that's going to be default layer, cell coordinates, tileset ID, and then from cells, we can use our key provided here as a cell type and pass the cell type to read the value. So basically to read the atlas coordinates, right? And then here we can just call set cell with cell coordinates, and type is going to be default. Let's see. Set tile cell, of course. Now it should work. And if we hit play, we have our tilemap generated, but it does not do anything yet. So let's take care of placing mines in the next section. See you. So after we generate our tilemap, now we would like to place the mines under some under our tiles that we have. So let's write a new function here. We'll call this place mines. Okay, and then we just need to write some stuff. Let's start by looping the number of mines, and then we need to get some random cell coordinates. Okay, so we get some random cell coordinates from the range of the tiles that we created. So this is minus rows divided by 2 to plus rows divided by 2 minus 1. And then the same goes for columns. Sorry, that's rand in range. Minus columns divided by 2 to columns divided by 2 minus 1. Okay. And that gives us random cell coordinates within our, too much. Yeah. In our generated tiles. Okay. But we cannot work with that out of the box, because as we're generating those random values, for example, if you have to place big amount of mice, because that's the value that was provided to you here, it may happen that you have chosen the same coordinates that was chosen before in the previous iteration, so we have to check against this. We can do this with simple while loop, and to do that we'll need to store the information about our cells that has mice. So we can just do cells with mines, and that's an empty array for the start. And then I can say while cell with mines has cell coordinates, what we'll do is we'll just try and find different random coordinates. Okay, and if that's not the case and we have unique random coordinates, we can just go cell with mines append cell coordinates. And after that, what we can do, is, oh, the problem is right now is if we go to our tile set, right? What we have is we don't know which cell actually has a mines. We don't have that information, right? Because we know it's gonna be looking like this, but we don't know whether this is empty or it has a mine. But we can help with that. We can go to Paint, select Property Editor, and then if we go to Tilemap and Layers, is it here? Let me find it. You have to click on the tile set, and then we have custom data layers. You can add custom data element, and that's going to be named has mine and going to be of type Boolean. And what we can do is say that we are painting this property and none of these tiles actually has a mine. You can see that the checkbox is empty. If I'm going to change it with a plus, right? If I'm going to do select, then it's going to have like this tick. But I don't want that. What I need is a tile that looks exactly like this, but has a mine, so has this tick in. So what I can do is right click on it and choose create alternative tile. And then I can select this one and say that this alternative tile has a mine. Okay, so you have two of the same tiles, one of which has a mine, one of which hasn't, right? And what I have to do now is to repaint some of my tile in the tile map with that alternative tile. And let's see how to do it. So here I already have my cells with mines, so I can say for cell in cells with mines, I can do erase current cell from default layer, and I can pass the cell here. And then I can set new cell, but we have to use set cell, the method from the tile map, instead of our own set tile cell, because we have to provide more information here. So default layer, cell, tile set ID, that's going to be a default, right? But what we're passing here is 1. And you can see that this parameter is responsible for alternative tile, because I would like to use not the standard tile with the number 0, but that alternative tile which has, as I hover over it, the very same atlas coordinates, but this alternative parameter is different. So I can pass 1 right here. Okay, so yeah, basically that's it when it comes to placing mines. We'll see that this is actually working when we will start working with the click event in the next section. Now it's time to start working on user input in our game. So to do that, we'll utilize the input callback, which gets input event from Godot engine. So first thing that we have to do is check whether our event is actually mouse event and not something else like mouse movement or keystroke from keyboard. So what we're gonna use are early returns, because I don't really like nesting if. So if event is not input event mouse button and or event pressed, I believe is the property, or yeah, the pressed should be property. even though autocomplete says not. Event press is not true, we'll just return. And then we'll print the event. Expected not type specifier after is okay. So let's do this, and that should work the same. Let's try this, and nothing happens. There's no there's nothing printing. I'm pressing keystrokes. Nothing is being printed, and now if I click, I get the information about the event. And even you can see here the information about position being displayed, but what we need is actually the information about the cell coordinate being clicked, right? So what we need to do is we need to transform that information about the event and the mouse press into cell coordinate. And we can do that by saying clicked cell coordinate is local to map get local mouse position. And now if I'm going to print that, let's see, this is -4 -4, and this is correct because we have 8 cells and 8 columns and 8 rows. This should be 3 and 4, and this is correct because that's -4, -3, -2, -1, 0, 1, 2, 3, and then here we have 3, 3 because -4, -3, -2, -1, 0, 1, 2, 3. Perfect. So you have that information. The next information that we need is the information about which button was actually pressed, because we'll utilize left button to check our tiles and then right button to place the flags in our minefield. So if event button index, and this is going to be 1 for the left click, we will call on cell clicked function that we're going to write, passing clicked cell coordinates. Else if event button index is equal to, we'll place flag. Okay, but we'll do that later. So what we have to do is to write that function, and if you don't know, you can just hover here to collapse the code that you don't need to modify for now. So we have cell coordinates, and that's vector to I for integer, and you can start working on that. Okay, so first thing that we need to check is whether we actually clicked on any cell that has mines. Okay, so if cells with mines, any function, and we can write anonymous function here, and this is one of the lambda functions from the functional programming paradigm. Here we are checking for whether any of the cells in this array returns true for that function. So in that array, is there any entry that makes that function that you write here return true? Okay, and the function is pretty simple, so we can write this in line. If cell x is equal to clicked, cell coordinate x, and cell y is also equal to cell coordinates y, then we know that we have just pressed on a cell that has a mine. So I can just do I can just say print you lose, right? And if not, well, then we have more complex problem, because we have to check how to actually expand our minefield, right, in the Minesweeper. Because if you click on an array that is on a cell that is neighboring any other cells with mine, we should display the number of mines in our neighborhood. But if we click on an empty cell, then it should expand and stop expanding whenever every other neighboring cell is next to mines, just like in original Minesweeper games, right? So this is the situation. This is a completed game when I'm clicking on a cell and I know that it's not gonna expand because there's already one mine in the neighborhood. Damn it. But as I clicked on here on an empty cell, right, it's gonna expand until all the external, or I don't know, outward cells are close to any mine. Okay, and we have to implement that. And I believe this is a good time to stop that section, and we'll go with that algorithm in the next section. So in this section, we have to write the algorithm to recursively expand our empty cell that we click. And I'm going to say recursively, meaning we will be creating a function that calls itself until the need to stop occurs, right? And I really should record an episode on a recursive function in GDScript, but I have so much stuff to record. But let's try this. First, we will need to remember the cells that we have already checked. So cells checked recursively, hard word. And then we can go here and start working on that. So we will say that cells checked recursively, we have to append the cells on which we clicked. So cell coordinates. And then what we will do is we're gonna create a function called handle cells. Right. And it's gonna take few parameters. It's gonna take the cell coordinate, and that's gonna be vector to I. It's gonna take a callback that should happen whenever we hit a mine, and that's gonna be callable. And callable is basically interface for a function. So we're gonna pass a function here, and then the information where we should stop after callback. And we need all those parameters because we will be calling that function in two scenarios. Once when we press directly on the mine, and the other where we, or do we need this? Because if we hit a mine, we handle this, so maybe we don't need it after all. Let's maybe try simplify this. If we can, that's gonna be good. So handle cells. Let's see. First, what we need to obtain is the tile data, and that's gonna be if we go to our Tilemap, where is it? Right, that's gonna be the information about whether we hit a mine or not. You can get that by saying get tile, get cell tile data, and we pass default layer and we pass cell coordinates. And if tile data is equal to null, we simply return, right? Because that means that what we did is we pressed outside of our tiles, because here also is our tile map with cell coordinates, but we're only concerned with those that have the tile data. Let's check whether this tile has a mine. So cell has mine. That's going to be tile data, get custom data, and the custom data layer that we are interested in is has mine. Okay. And then if cell has mine, what we should do is return, and basically what we should do is nothing here. Yeah, we should just return. Cool. Because we hit a mine, but that should be basically handled by this scenario here. And then what we should do is we should check what is the mine count for that tile we pressed, meaning which type of this 8 should we display, right? And we write a helping function called get surrounding cells mine count with the cell coordinates. So let's write it. Get surrounding cells mine count with cell coordinates, and we know this is vector 2i. Okay, and that's gonna be pretty cool to write. So we'll say that mine count starts as 0, but then we get the surrounding cells by calling get surrounding cells, and this is again coming from the Tilemap, right? From the class that we're using, from the node that we're using, for cell coordinates, and then for cell in surrounding cells, we say get tile data, get cell tile data, default layer, cell, and then if we have tile data and tile data get custom data as a mine, we simply increment the mine count. That shouldn't be here, and then we return the mine count. Right? So what we are doing is after the press, right, we just take the surrounding cells and see how many of these has a mine set to it. Very simple. So we have the mine count now, and then we have to decide what to do if the mine count is equal to 0 and what to do else. And for the else case, we can just say set cell, and that's going to be cell coordinate, and the cell that we want is just the mine count, right? And we have to cast the mine count to string because the keys in our dictionary are strings. Okay. But what to do when the mine count is set to 0? Then we should check all the surrounding cells and see whether those have any mines around us. So we can, for starters, set this size cell under cell coordinates to clear, and then get surrounding cells, get surrounding cells by cell coordinate, and then for cell in surrounding cells, you can say handle surrounding cell by cell, and that's going to be the function that we will write. Okay, so what to do in each cell that surrounds us? Handle surrounding cell first. We need to check whether a given cell was checked recursively. If so, nothing. We'll simply return because that cell was already checked. If it wasn't checked, we will append it to our checked cell array, and then we'll simply try to call handle cells by cell coordinate. So what we're doing here is this recursive function call where we call the handle cell on the first cell that we click, and then for each surrounding cell, right, we are moving to that function, but it calls the function that called that function. So basically we're calling this function in a loop until there's a reason to stop this recursive loop. One of the reasons is that this cell was already checked, right? And this may happen because if I'm checking this cell, right, for its surrounding cells, which are these, right, and then I click on that cell, then this cell was already checked by clicking on this cell, right, for the amount of mines. The other reason to stop is the mine count, right, is not 0 for a given cell, right? In that branch of code, we're not calling handle surrounding cell and handle cells. So there are reasons for our recursive loop to stop. There are problems with writing recursive loops if you're not writing them correctly with good if checks and the reasons to stop. They may end up being an endless loop, which is gonna overflow your memory and is gonna crash your game or your software. Okay, let's check whether this works, and I can see it does nothing for our case. So let's see what is wrong with our code. And I think it's not going to work because we simply don't call handle cells with cell coordinate. So let's try this now. And everything is empty. So that's not good, right? Okay, let's see what is wrong. And I think I know what is wrong, because we here, if stock has a mine, is it we return stopping the function, but that should not happen in every such case. So the parameter here should stop after mine. It's gonna be Boolean. We're gonna set this to false. So here we're gonna do here we're gonna do if has a mine and should stop after mine, then return. And we're calling this let me think. How we're calling this here, paste mines, no, here on cell clicked, here we should pass through. Let's try now. No, it's still all empty. That's so silly of me. What we should do is, of course, call place mines in the ready function. So now I can see that everything is expanding properly, but what I would like to find is the numbers are incorrect, because for example here we should have number 2, right? So the number that the placing of the mines works and the expanding works correctly. Oh, here's 2, 1, right? But I believe, for example, here, or maybe it does work. Let's see, let's test this by changing the number of the mines to 2. And this is 1 and 1, or maybe actually bumping it up to, let's say, 20. And let's see. Okay, I believe this works correctly. Right, and what I could do is maybe change the camera zoom to 2, so it's better visible. Yeah. Okay, so I believe what we have right now is working actually pretty good. And if we click on a mine, it says you lose. So let's handle that. We have that expanding algorithm working. Again, what we're doing here is recursively calling handle cells function. Next, let's handle actually pressing on the mine itself in the next section. So let's handle the losing state of our game. I'm going to start by actually creating few signals that we will emit from our mines grid, and that's going to be flag change signal, flag change with the number of flags, and we'll need that later, and one signal for game lost and one for game won. Okay, and with that we can handle the losing state. So what we need is also clicked and Then here where we handle the loose, so we say loose with cell coordinate, and we're gonna write a function for that. So loose with cell coordinate vector to I. So first we're gonna emit the information about our game being lost. Then we will also, what we'll also do is get a flag here, is game finished, and it was gonna start with false. And here we will trigger it to true. And then for cell in cells with mines, we will say set tile cell cell mine, and then after that loop is finished, set tile cell coordinates mine red. And let's see how that works. So I'm trying to hit a mine, and here we go. Everything is displayed very nicely, right? And after we're done with the board, we'll display some UI, to inform the user about what is happening. But this is the losing state for our mine tiles. The next big feature that we'd like to add to a game is actually using the right click to place the flag. So let's go back to our place flag, right? And we'll simply replace that print with a function called place flag with click cell coordinates as a parameter. We can go down and start working. So place flag, that's gonna take cell coordinates vector to I. And what we're going to need is another array up here, cells with flags. And we can start working. So file data is going to be get cell tile data, default layer, cell coordinates. Then we need to get the we need to get the atlas coordinates for that cell, because we need to know whether this is already, whether this is empty cell or a flag. We can say get cell atlas coordinates. This is also a function that we get by inheriting from the extending the tilemap. And here I can say default layer and cell coordinates. And we can use that information to know whether we clicked on an empty empty cell or a flag, right? So is empty cell, and if we clicked on an empty cell, basically we can know that because the atlas coordinate for this is 2 and 2, right? So I can just write atlas coordinates. So how do I know that? Because I can just, because we cannot place the flag, or we shouldn't be able, on an empty cell. This was already like checked, right? And basically on any other flag here, right? It would make no sense. So given the fact that we know the atlas coordinates, what we're interested really in is only placing the flag here on a cell that is empty. So if is this empty cell, and I can say it is if the atlas coordinates are set to vector 2i, 2 and 2. You can place our flag, right? And then is flag cell, and I can know that, right, by saying our atlas coordinates set to, and the flag is atlas coordinates for that is 0 and 2. So that's vector 2i, 0 and 2. Okay. And then what we also would like to know is the amount of the flag that we've already placed. So flags placed is 0. Okay. And we can continue. So if this is not empty cell, right, or it's not flag cell, right, we simply return, because you cannot place that on the cell that is that has no basically you can only place this on default cell or flag cell to toggle the flag, right? Okay, so now let's handle the case where this is cell with flags. I mean, is flag cell, sorry. If this is a flag cell, we should trigger it back to default cell. So cell coordinates and set this back to default. And what we should also do is if this cell coordinate exists in cell with flags, we should erase that. Right? I mean, we no longer store that information. And then we should also decrement the amount of the flags placed. Right? So basically, if that was the cell with a flag, we remove the flag by triggering that tile back to default, erasing that information that this is a cell with a flag from our stored array, and decrementing the amount of flags placed. Else, right, if this is an empty cell, is empty cell, and the empty cell meaning the default cell that we can place a flag on, right? First we check if flags placed is equal to number of mines. If so, we cannot place any other flags because that's the limit. There's a limit to flags that we can place, right? Because other than that, you could just place the flags all across the board and you would win the game because you flagged all the mines. Then we increment the amount of the flags placed. We set the tile cell coordinates to flag, and what we do, we say in cells with flags append cell coordinates, and in the end we emit the information about the flag change with the information about the amount of the flags placed. Okay, and this should basically work, I believe, if we wouldn't hit a mine already. And it is not working, are we calling this? If it's not empty, let me see, place flag, handle the input, place flag. So that should place our flag. Yeah, what we should do is definitely change that or being an and. Just to remind you, those 2 ampersands basically used for the Boolean operations in GDScript can be replaced by and. So if it's not empty cell and it's not flag cell, then we should return, right? And then can use the right click to place some mines. Okay. What I would like to change is bring back the zoom for now. Right, so I can toggle those, paste those, and those cannot be placed in the mines, in the fields that are not empty or flags. So this is cool, and we can flag our mines. All right, now the other thing we should do is actually use that function to check whether we have won. And to check where we have won is simply to check whether the each flag cell is placed on each mine tile. So let's add a simple count here. And for flag cell in flag cells with flags, and for mine cell in cells with mines, right? If flag cell X is equal to mine cell X and flag cell Y is equal to mine cell Y, count plus equals 1. Okay, and then if the count is equal to cells with mines size, we simply win. Okay, so and then how can we test this win condition, right? Well, thankfully we designed that to be very simple, because what I can do is set the columns to 2, the rows to 2, number of mines to 2, and try and solve that puzzle, right? So I press here, okay, that did not work. Let's try again. Okay. There's a 1, and then I have to be very lucky, damn it. So, okay, I'm gonna just try to find the 1. Damn it. Random number generator. Okay, and then I'm gonna start flagging stuff. Okay, so that's not correct. And now you can see I flagged the mines, right? And I got the win. Let's try this again. Here and here. Yeah, so here is no mine. There's no mine here, right? So let's bring back those values. If you flag all the mines, you win. It's as simple as that. Cool. What else do we want? This is pretty simple, because we can just say let's get a very simple win function here going. What we'll do is we'll say is game finished, and we will set this to true, and then we will emit game won. And I believe one thing left for us to do is actually use this is game finished. And if we go to the input, just not to break anything, we can say if is game finished, then do not process any input. And yeah, game is finished and I cannot click anywhere. Okay, perfect. That basically sums up the logic of the game, but in the next sections we'll work on a simple UI to display all of the relevant information to the user. So I'll see you in the next section. So in that section, we're going to work on our game state manager and our UI, two other nodes that we need. And as you can see, this game is rather simple. It's not very complicated when it comes to the amount of the nodes that we use. So let's start by adding game state manager, and that's going to be empty node. And we're going to just add a simple script here. So move to the scripts folder, name this game state manager. Okay. What we'll need here though is we'll save branch as scene because we will need one thing added here. So we're now in the scene, right? Let's click add child node, add a timer, and let's start working. So we'll need few references here. First is to the mine grid. So mines grid. The other is the reference to our timer. And what I'm doing here is just clicking, dragging, pressing Control, letting go to get that reference. Also time elapsed 0. Okay. Ready. Let's connect to the events, to the signals here. So we have game lost, connect on game lost, mines grid game 1, game 1 connect on game 1. We'll have to write those functions, mines grid flag change connect on flag change. And just to be sure, let's see, flag change is being called exactly once, and this is not correct, I believe. So we will have to fix that, because in our mines grid there's a possibility that we click on a cell that already has a flag in it. So in on cell clicked, we have to check if cells with flags has this cell coordinate. We clicked on, we left click on a cell with flag, so we have to do flag space minus equals 1 and flag change emit flags placed. Let's see. Oh, also there's a possibility that we do very same, and what we should do is probably also do cells with flags erase cell coordinates, and we should do the very same whenever we handling our cells. So handle cells, and here's the other case in handle cells at the very bottom, because as we are expanding our cells, there might be a situation where we hit on a cell with a flag that is also empty underneath, and then we should erase it. Okay, so with that fix, we can go back to our game state manager. And what we should do is probably connect to a timeout. So on timer timeout, what we do basically is call time elapsed plus equals 1. And then we should do on game lost and on game won. And on flag change, we can also write that. And say UI set, oh, we don't have UI yet. Let's say flag count, or better, flags count. Okay, so we have that. The only thing left for us to do is to build the UI. So go back to main and let's create new scene. We'll use other node, we need canvas layer. And let's start working on setting this one up. So what we need is, let's see, we will need a panel container. Okay, we need for it to stretch across. We need for it to have a custom minimum size of 40. Okay, and let's save this. Let's name this UI and save as a scene. Then we need hbox container. Okay, and we need to set it in the middle, and here we need to give it a size. I don't think so, but we definitely need another panel here, and that's gonna be mine count panel. Then we need another node, which is gonna be texture button. That's gonna be game status button. And we need another panel. And but like here, and we're gonna call this timer panel. And we need a label. We'll call this mines. Let's change that to mines count panel, and that's gonna be mines count label. And here we're gonna have another label called this timer count label. And that's pretty much all of the setup. And this is horizontal, so that should be good. We need to start bringing some informations here. So I'm gonna say that's gonna be 100 for now. At least we're gonna start with that. Then we have to start working on our panels. So custom minimum size, I set to 50 and 30. Then what else? The theme override styles, make it sidebox flat, make it black. Then this one, we should be able to set it to the middle. And then for the label itself, it should be center and center. Perfect. The very same settings we're going to apply to the second label. So go to layout, 50, 30. It could be 000 for now. Center. Also set this to center for now. And theme overrides. Oh, that comes in a second. Here we're gonna do theme override styles, new sidebox flat, black. Okay, and this should have 50 and 32. Okay, then we need to bring in our asset and our font. So click on both labels, theme overrides, fonts, and we can drag and drop that font. I have a font size set to, let me see, 25. And then the color is font color all the way to red. That's perfect. That's pretty much it, but in the middle we have to handle our button. So the button, we have button smile for normal, button smile pressed for pressed. Okay, and I can tell that these are a little bit too close. Maybe, okay, let's align it vertically. Let's change the texture to nearest filter, so that's that's sharp now. Then go to hbox container, and what we can do is find this call, I believe, what's the name of that property? Separation. We can filter that and find the separation and set this to 20. And we have our UI pretty much done. And we can code that UI, place this in scripts. Perfect. Well, first thing that we need are some references. For example, to the mines count label. And if I drag and drop this with control, you see that we have to traverse the whole tree of nodes to get that label, right? Because we're going down the tree. But better way to do it is to right click on a label that you're interested in manipulating in your script, and then choose access as unique name. And now if I drag and drop it, you can see that this is shortened and is now accessible not by a $sign, but rather with percent. So I'm going to do that and set access unique names to every single one of the node that I'm interested in. Drop this. Let's give it a class name. We also need the access to the textures that we're interested in. So game lost button texture, and this is preload, and I believe this is dead. Yep. And then game one button texture, preload, and this is cleared. Okay, so they're gonna be preloaded, and we will use those to change the button texture. So we have to write a few functions here. Set mine count, the mine count, and what I would like to have for my labels is that whenever I have one here, it is not displayed as one, but rather as 001, because it looks cooler with that font, right? So what I can do here with code is say change the mine count to string with the str function, and then check if mine count string length is less than 3. Then we can say mine count string is equal to mine count string, and there's a function called lpad, which say it's gonna append some kind of characters or strings from the left to the maximum amount of to the minimum length of that string. So if we do something like this, right, it's gonna take that string and make it at least 3 characters long by appending a 0 character to the left side of the string. And I can just say mine count mines count label text is equal to mine count string, and it's to make it more correct, we should use the plural here. At least that's what I think. As you can tell, English is not my native language, but that looks more correct and sounds more correct. Okay, set timer count. This is gonna be very similar. So convert to string, check for the length, and length is less than 3. Time string is equal to time string lpad 3 0. Timer count label text is equal to timer string. Okay, and then we have to connect to the pressed event of our button in UI. So let's go to node signals, and we have that one. And I can simply reload, get 3 reload current scene, and then game lost function will take the game status button and change the texture normal to be game lost button texture, and game 1 will change the game status button texture normal to game 1 button texture. And we're gonna get all of that code and hook it up to proper calls in game state manager. And we're doing that interim class, that node, just to basically separate our game logic from the UI, right? So they're not directly connected. I believe this is good when it comes to separation of concerns. And basically, the less the nodes know about each other and the less they're tightly coupled, the better. So here we can say that we need reference to UI. Okay, and I can just say set mine count. This is taken from mines, read number of mines. Whenever we change the flag, we just call UI set mine count mines read number of mines minus flags count. That's correct. On time elapsed, we say UI set timer count to time elapsed. here we just, on game lost, we say UI game lost. Here we have to call this, and then UI game one. And that's pretty much it. Yeah, of course, we have to pass those references. They should be available here, and they're empty now, so we have to assign those. So we can just drag and drop this, and also we have to instantiate our UI here, and then also take this and drag and drop this. And now it's not going to work because this is going to break because of the order of the nodes. If you don't know, in Godot, the nodes are being instantiated and set to ready from top to bottom. So because our game state manager relies both on our UI and Tilemap being ready, we push it to the bottom, and now it should work. And basically, the timer is not running, but we can just go to game state manager scene, click on our timer and choose auto start. And now the timer is running, and if we hit it, you can see that the face in the button changed to sad and dead. And now if I press it, it's gonna restart. I probably could also solve that if I had the time, but yeah, I'm not very lucky in that game, as you can see. So, but basically it definitely, there's a mine here. It should work properly. Let me know if you have any kind of suggestions. If you're happy with that, I highly encourage you to work more on it. Maybe add a different level of difficulties, maybe add a letterboard, build more extensive UI. It can be all achieved rather easily. Thank you. I would really appreciate it if you could like and comment and subscribe. Preparing those tutorials take a significant amount of time, but I'm really dedicated to making those and educating people about programming and Godot, because this is really such a cool piece of open source software. It's perfect. I hope to record more in the future. I hope to record about AI in Godot, about making games in 3D, and also I will be preparing a special Halloween episode because I love Halloween. So thank you, and I hope I'm going to see you in the next one. Goodbye.